Now, what are functions to first of all begin with? See, very loosely, in our day-to-day lives, we talk about functions. For example, if we start taking examples, a lot of times when whenever we deal with, let's say, economy as a whole, or whenever you're talking about employment of people, you come up and you say that, my employment depends on how the economy performs as a whole, or my employment or my salary depends on how much is the economy growing as a whole, right? Or, let's say that my pocket money, for that matter, depends on how much my family's income is. My education depends on how much my family income is. So very often we go ahead and we loosely speak about the relationship between two or more things. We kind of go ahead and say that, what, how much ever this economy is performing. And why I'm giving so much examples of economy, because you have to kind of relate this back to economics. This maths is actually mathematical methods for economics. How do I take it back to economics and apply it in economics? So, a lot of times we go ahead and say that, how my economy is going to perform is going to depend on what the government's expenditure is going to be, or what the fiscal deficit is going to be. So more often we kind of use these things very, vaguely or very loosely speaking. Now, when we try and give relationships a mathematical form, that is what forms my function. So what is my function? A function basically is when one thing depends on other factor. For example, my agricultural output depends on the rainfall. For example, the cost of a firm depends on the amount of labor that it has employed. So when one factor or one variable is dependent on the other variable, then that is what is known as a function. Usually, whenever we speak of functions, we always talk about two things. One is known as an independent variable, and the other is known as a dependent variable. Now, what is an independent variable? An independent variable is any variable where you are not going to derive the value, where the value of it would be given to you. For example, I cannot derive the value of the rainfall. You will give me the value of rainfall, and based on the value of rainfall, I will go ahead and I will tell you that this is the amount of agricultural yield that I have. So, the independent variable in economics, and because you have now done microeconomics and, you understand what is exogenous variable, what is endogenous variable, the independent variable is an exogenous variable. It is determined outside the model. The value of it is given to you. And based on the independent variable, you derive the value of the dependent variable, which becomes endogenous variable, something which is determined within the model. So agricultural yield will be determined within the model and hence endogenous. Utility will be determined within the model and hence endogenous. Prices will be given to me when I talk about competitive equilibriums and hence exogenous. So, one activity that I kind of find very useful for you is for you to relate back economics and maths together. So here we are studying pure mathematical methods. But how does it really apply to economics, to the fundamentals of economics? That is what your interest should be. Because at the end of the day, you are going ahead and becoming an economist. So let's go ahead and see and deep dive a little into this. Now, what is a function to begin with? One variable is a function of another if the first variable is dependent on the other. So I can go ahead and form as many functions as I want. Agricultural yield is a function of rainfall. Your happiness is a function of your pocket money. Your parents' happiness is a function of your marks. Your educational level is a function of your determination. Salary is a function of gender. I can go ahead and form as many functions as I want to. What is the only thing that I want to understand? One thing depends on the other. One thing depends on the other. Salary depends on the gender. So what depends on the other is a function of the other thing. Let's see a few more examples from maths. So when I say y is equal to x square, I am going ahead and saying that y is a function of x. When I say C is equal to 5 by 9 F minus 32, which is nothing but a relation between centigrade and Fahrenheit, I am again saying that centigrade is a function of Fahrenheit. You put in some value of Fahrenheit and you will get a corresponding value of centigrade. You put in a value of X and you will get a value of Y. So, these are the various examples that I'm talking about. Your utility is a function of your pocket money. So supposedly I tell you, let's go a little economical. And in economics, I tell you that your utility is, root of pocket money. Suppose. So you put in a value of pocket money. You put in 100 here. You find its root and you get utility. So your utility becomes 10. You put in another value of pocket money, 200, and you get 2 root 10. So different values of pocket money give you different values of utility, right? Similarly, I can say that cost is a function of labor employed. The more is the labor, the more is my cost, because more is the salary that I will be paying. So, one doesn't really always require maths or mathematical functions to work with. Individuals can go ahead and express this relationship using tables, using graphs, using charts, etc. So, for example, let's see this. This is a diagram that I picked up from macroeconomics, and this is a diagram for Laffer curve. Now, Laffer was an economist who came up with this curve, which said that as the government keeps on increasing the tax rate, as the government keeps on increasing the tax rate, the tax revenue will also increase. So tax revenue is tax rate into income. So if you are collecting 10% of your income, you're collecting a particular tax revenue. When you collect 20% of your income, you're collecting a particular tax revenue. When you collect 30% of your income, that becomes your tax revenue. So he said that as you increase your tax rate, the revenue will initially increase. It will reach a maximum. But supposedly the government tells you that I am going to go ahead and charge 100% of your income as tax, will you work? No. If I earn 100 rupees and I have to pay 100 rupees as tax, I very well may not work. So, if the government charges exactly 100% as tax, then the tax that the government will collect will be zero, because nobody will work. If the government charges 90% also as tax, there will be so many people who will leave the labor market, because they will think, why work? Out of 190 government takes, I'm only left up with 10. There is no reason why I should work. So the Laffer curve suggested that as the tax rate increases, initially the tax revenue will increase. It will reach its maximum, but after that it will start decreasing. And now understand that here again I am expressing a function. I am saying that the tax revenue collected is a function of what the tax rate is. And because I am going ahead and giving a function for it, even without mathematical form, this is a function. Similarly, if I tell you that, this is my price and this is quantity demanded. And I tell you that when price is 10, quantity demanded is maybe 5. When price is 20, quantity demanded is 2. When price is 30, quantity demanded is 1. I am telling you a relationship that the quantity demanded depends on the price of the commodity. And as the price increases, the quantity demanded decreases. So there is this negative relationship between them. This is also a function. Price is independent. Quantity demanded is dependent on the price of the commodity. So I can represent the relationship in form of a table, in form of a chart, or very well in some mathematical format. Well, in this chapter, although I would be dealing with mathematical formats, it is advisable for you to, kind of think of everything that you do in micro or macro as functions. So whenever we say that consumption depends on disposable income, consumption is a function of disposable income, right? Okay. So now I want to kind of go ahead and talk about a rule here. So a definite rule. Now you have to understand that for now, I am saying that each value of the variable gives me a corresponding value of the function. Which means if I tell you my function is x square, I put a value here, I square that up, I get a value of the function. I put a value here, I square that up, I get a value of the function. So putting values for x gives me values of the function, right? So let's now formally define what this means. Let's see the definition of function. A function of a real variable x with domain D. I will talk about domain and range a little later in much detail. But for now, you just have to understand this right here. So a domain is something, is a space to which my x belongs. So, I can go ahead and say that x is always a natural number. I can go ahead and say that x is always a real number, but positive real number. I can go ahead and say that x is a real number. I can go ahead and say that x is maybe integer or maybe rational number. I can define the space over which my x will exist. And that value that I'm defining over which my x will exist, that is known as my domain of x. We'll do it in detail, but for now you just have to understand the space to which x belongs. That is the domain of x. Now we are saying that we go ahead and we define this variable x, and this variable x is defined with a space. So we are saying that, you know what, this x belongs to this place. It belongs to natural numbers. Whenever you put in any value of x, it will always be positive. For example, price and quantity. Whenever you put in any value of price, it will always be positive. Whenever, for example, cost is a function of labor. Whenever you put in any value of labor, it will always be positive and discrete. Labor cannot be 1.5, 1.8, etc. So, unless you're finding labor in labor hours. So, I am saying that for each x, I have a domain over which it is defined. Now, we are saying a function of real variable x, you can put this in bracket, with domain D, is a rule. So a function is a rule. What does this rule do? This rule is very simple. It picks up the value of x and it assigns a unique real number to each value of x. Right? So for example, please understand. For example, if I tell you that x is defined such that it can take 5 values, 1, 2, 3, 4, 5. And now I say that the function of x is nothing but the square of x. Then what is this rule going to do? This rule is, what is function going to do basically? It is going to pick up an x. It is going to plug this value of x inside this function. So it is going to plug 1 instead of x. It is going to get the answer for you. So the answer is 1. Again, it is going to pick up another value of x because x is defined over 5 values. For that value of x, it will give you the value of the function. So it can do it for all the values of x. It can give you the value of the function. So let's read this again. A function is nothing but a rule. It picks up values of x and it assigns unique number to the value of x. Whatever value of x you will pick up, corresponding to that value of x, the f of x thus defined will be unique. It will give you one answer for that. Now, this rule can be given by a formula, as I just said. Either you can represent it mathematically, or you can just say it in words, like the Laffer curve in words, like the law of demand in words, or you can define it by a table, like we just made a demand schedule, or you can illustrate it by a curve, like the Laffer curve. So, you can go ahead and define function in any of these ways. In case of a formula, in words, in table, in curve, etc. Now, a function is given by a lot of ways. One way to write the function is simply small f. So I can say y is a function of x. The other way is any small alphabet. I could have very well written y is a function of x, but instead of f, I would have used g. I could have written y is a function of x, but instead of g, I could have used h. So anything is fine, any small alphabet. Similarly, I can also use any capital alphabet. So I could have written y is a function of x. This is also one of the way to note this down. And you could have also gone ahead and represented by any symbol. That would have also been fine. So you could have written y is a function of x. this would have been equally fine to work with. So you can go ahead and express the function using small alphabets, large alphabets, capital alphabets, or using these phi's or anything else. Any symbol can also be used. Now, you have to also understand that if I am saying that, whenever I'm representing f of x, then ideally, this is simply saying that f of x, this just is, how do you read this thing? This simply says f of x. So if I say gx, then this is g of x. That is how you're going to learn, how you're going to go in and mention this. When you read it out, this is how you're going to read it. So for example, let's say, if I say y is equal to hx, so I'm saying y is a function of x. But if I do not give you y and I just say hx, then you're going to say h of x. Okay. Now, let's go ahead and, this is something I've already mentioned to you, that x is always the independent variable and y is the dependent variable. So y depends on the value of x. X is exogenous. It is defined outside the model. So if I talk about maximizing utility subject to budget constraint, then price and income are exogenous. But x and y, how much of good x you will consume and how much of good y you will consume, that is endogenous. Right? Similarly, if I say maximizing profit, let's say subject to cost or subject to the level of output. Again, you can go ahead and define exogenous and endogenous. I'll do this. When I go to the production side, I will again come back to this part and I will tell you exogenous, endogenous, etc. So, you have to understand independent, exogenous, dependent, endogenous. Now, let's talk about certain functional notations. So this is one of the first examples. This says, let's see, very simple. Assign to any number the third power of that number. So I'm saying any number is the third power of the other number. So whenever you put a number here, its third power becomes the next number. Simple. I'm just saying y is equal to x cube or f of x is equal to x cube. That's it. You put 0, you get the answer as its third power. You put 1, you get the answer as its third power. You put -2, you get answer as its third power. -2 into -2 into -2. You put 1/4, you get answer as its third part. 1/4 into 1/4 into 1/4. You put a, and now this is a little tricky, and I want to kind of again hold you for a second for us to understand a and 1 plus a. Now please understand, if I put a in f of x, I will get a cube. If I put 1 plus a in f of x, I will get 1 plus a whole cube. And you can open this up. All of us know the formula of a plus b whole cube. It's a cube plus 3a square b plus 3ab square plus b cube. That's fine. But this is what I want to highlight, that when you put A, you get A cube. And when you put 1 plus A, you get 1 plus A whole cube. A lot of students go ahead and instead of writing 1 plus A whole cube, actually write down A cube plus 1. This is wrong. 1 plus A, if you're putting it in the function, you have to replace x with 1 plus A and then cube it. I want to give one more movement to this thing, to this analysis. So consider the volume of a cube. The volume of a cube, the formula for volume of a cube is its side cube. So if the length, because for a cube length, breadth and height are the same, so if its side is valued at A, then the volume of the cube will be A into A into A. Simple. That's the volume of the cube. I want to give it a movement that A cube plus 1 and 1 plus A whole cube are not the same thing. So supposedly I begin with the cube whose side is A. The value of the side is A for this cube. And now I tell you what will be the volume of the cube. You will tell me, okay, this is the cube and its volume will be simply A cube. Side into side into side. Now I'm saying, consider another cube whose value of the side is 1 plus A. Because now in the other question, I am saying that x is 1 plus A. So consider another cube whose side is 1 plus A. Then when its side is 1 plus A, length, breadth and height, all three of these values are increasing by 1. Are you getting it? So actually this is like this. Each side, whether it is length, whether it is breadth, whether it is height, is getting increased by 1. Each side. So now for this cube, this length is actually 1 plus A, breadth is also 1 plus A, and height is also 1 plus A. If I ask you what will be its volume, you will tell me 1 plus A whole cube. If I ask you what will be this volume plus 1, it will be A cube plus 1. So A cube plus 1 is volume of cube which has the side as A, and you're just adding 1 to it, which means nothing. And here you're finding the volume of the cube whose side is 1 plus A. The two things are very, very different. Okay. So, A cube plus 1 is just implies volume increasing by 1 unit, but the side is still A and not 1 plus A. So make sure that you put this in the right part. You have to put 1 plus A instead of X. That is important, and not just add 1 to it. Okay. Now, this is another question which is given to us. Let's try and solve this, and then I'll give you one for practice. So, this says that the cost function is given by 100x root x plus 500. And they're asking you to do 4 things with it. The first is find what happens when the units are 16. Very simple. Instead of x, you substitute 16 and you just get an answer. So this is 100, 16, 4 plus 500. So this is 6400 plus 500, 6900, and solve. Then it says put 100. What is the cost if you're producing 100 units? So instead of x, you will put 100. If you put 100, what will you get? 100, 100, root 100 plus 500. You solve this, you'll get 1, 0, 0, 0, 0 plus 500. So if you solve this, you will simply get this. Then this asks you, what is the cost of producing A units? If you have to find the cost of producing A units, then what will you do? Then instead of X, you will put A. So, cost of producing A units will be 100 A root A plus 500 and solved. Now it asks you, what is the increase in cost when you produce an additional unit? When initially you were producing 100 units. So it says initially the firm was producing 100 units, but now supposedly the firm produces A units, but now the firm produces 1 plus A units. So what is the cost for 1 plus A? We just mentioned, you don't just add 1 to it. This is wrong. You have to replace A with 1 plus A. So 100, 1 plus A, root 1 plus A plus 500. This is the cost of producing 1 plus A units. Now the question is asking, what is the additional cost? What is the extra cost you incurred? So this is the cost of producing 1 plus A units. This is the cost of producing A units. What is the extra cost that you had to incur? C of 1 plus A minus C of A. You just subtract this and you will get 100, 1 plus A root 1 plus A minus A root A. Because 500 and 500 will get cancelled. So the additional cost, and I'll share this also with you assignment. So the additional cost will be the cost of producing 1 plus A units minus the cost of producing A units. And if you go ahead and you subtract and you find the difference, well, 500 and 500 gets cancelled. So it will be just this minus this. You can take 100 common and this will be your answer. Now, in microeconomics, we refer to this as marginal cost. What is the additional cost that you incurred when you increased your output? But we are going to argue that, this is actually known as incremental cost. So, after some time, give me some time, when I progress few lectures later in maths, I will go ahead and I will distinguish between incremental and marginal cost. Although in microeconomics, you use them interchangeably, but in maths, incremental and marginal cost actually mean different things. So what they mean, I would be taking that in a few lectures, not now. So for now, you just have to solve this usually and get the answer. Now, one more thing that I want to kind of highlight is that always we write y is a function of x. Y can be a function of t. Y can be a function of h. Anything. Need not be the case that my independent variable is always represented by x. It can be represented by t. It can be represented by h or by any other thing. So, this is just saying I can, if I'm writing the function as this, instead of x, I can replace it with t. I can replace it with any symbol and I can replace it with just dots also. Where dots represent that you can replace it with any number possible and any variable possible. So, this is no convention that only x will be used to represent independent variable. You can use any alphabet to represent independent variable.